today. So thanks to all of you, and we must feel proud of it. So when it comes to the, as I asked, but somebody asked what exactly the low volume road. What exactly is a low volume road? So I say that basically the low volume road, the nomenclature that is used in the developed countries is the low volume road, where in India we normally use a rural roads. Rural roads comprising of the village roads and ODRs, the village roads and the other district roads. And as you are all aware that the village roads are the road within the villages. Whatever the agricultural production that has been created, that has been produced by the farmer, it must be transported to the nearest market center, so that which required a higher order category of the road, and so they can easily reach to the market center. So one of the idea, what I come across to the literature, one of the idea for developing this rural roads in that days, one is to get the farmer out of the mud. One of the motto is to get the farmer out of the mud. So to get the farmer out of the mud, then coming to the construction design aspect of the low volume road, I always feel that it is very easy. It is very easy design construction of the high volume road rather than the low volume roads, because in a low volume road we are all continuously striving for a cost effective technologies and cost effective construction methods and cost effective materials without compromising on the quality and performance of the payments. So to achieve this one and one, it is not that easy. That's why most of the people feel that low volume road means what is there? It's a low gradient road, low specification road, or it is simply nothing, simply a low grade specification. Anybody can construct. That's fine, but that's why it has been neglected. So I was just going through the literature. What is the definition of this, and how do you define this? So I'll take it as granted from me. Universally, there is no accepted definition for the low volume road as on today. The definition of the low volume road to try to define, it varies from the country to country, varying from the state to state, it varying from the agents to agency. Within the state, it is varying from the person to person or researchers to researchers. So I just started digging out the literature from the 1976, how the people are doing. So one study says that they said that low volume road can be defined as you can pick up like your own appropriate number. It doesn't mean that you say that 50, 70, 90, 100. So even the 50, 90, 70, 100, there must be a rationality to establish that number, and you can declare that road as a low volume road or a rural roads. And also so on. Somebody say, you can see here, they said there's a 400 vehicles per day. Transportation Research Board, one of the prominent research organization across the world, so they said that 400 vehicles per day. And if you refer to the literature, stating from not less than anywhere to the 100 is the lower limit to the 5,000 is the upper limit. This is what the definition that is a low volume road. But 70 to 80%, 80 to 85% of the old road agencies accepted as a 400 vehicles per day. 400 vehicles per day as defined as a low volume road. So right now, the planning, design, or the construction that has been done on the rural roads across the globe, on the face of the earth, 80 to 85% of the researcher road agencies are working within a definition called a 400 vehicles per day. And within the low volume road, there is also one more subcategorization, which is called a very, very low volume road. It is a very, very low volume road, which carries a traffic less than 50 vehicles per day. And you know that initially before the 2000, as I was telling, low volume roads are initially made up of or locally available materials, and everybody feels that in the low volume roads in India, low cost or low graded specifications. We must thank, as Professor Prasad sir mentioned in the morning, must thank the visionary, the late Prime Minister of the country, late the Vajpayee ji, who has thought about this scheme and brought out after that only the IRCSP 2002 rural road manual has come after the 2000s. That has become a Bible for everyone, and everybody might have seen this quote. Then followed by the PMJS scheme, then followed by the ODA practices for the flexible payment, rigid payment, and etc. and etc. And also recently a stabilization of payments also been added. Now the question you can ask me, sir, what is the scientific why we need to accept it is on 400 vehicles per day? So this says that the peak hour volume of rural road, I'm talking about the peak hour of the volume rural road, is about the 50% of the daily traffic. It is about the 50% of the daily traffic. So 50% the 15%, not 50, 15, 15% daily traffic. So 15% of the 400 is about the 60 vehicles per hour. If you further translate and see that one vehicle per minute. Now you're all worked within a rural roads. Now you try to recall back. Is there the rural roads? Are we getting 60 vehicles per hour? Are we getting one vehicle per each minute? That you try to recall and see. So that's why 400 vehicles per day is an accepted definition for working of the low volume roads. So these are the photographs. Mostly you can see hardly the two-wheeler or the auto rickshaw, and this is the picture. This is the picture during our visit we have taken. A B.Tech girl, two girls of B.Tech, a remote area village, because of lack of the cross drainage structure during the seasons. This is the way that they are crossing the road. Okay, and we know that what is the importance of the rural road, because the livelihood, the education, day-to-day activities, employment, agricultural, medical, whatnot, really depend upon, or all our life starts from the rural roads, low volume roads. So with this background, let me proceed further. So this is the definition of the low volume roads. Another way of things. So they are set by this low volume roads set by the combination of the typical vehicles using a road and a traffic volume on the road. So what they are simply saying that weights are simply divided into light and heavy, and the volumes are divided into low and high, with a limit of, as I said, 400 vehicles per day. So here in this picture, please note that, and also if you recall your traditional literature, traditional whatever the knowledge, sound knowledge that is available in the low volume road, it is concerned only with the lower left coordinate of the graph. This one, lower left, traditional low volume roads. Whereas in most cases, we also had a mining roads, sand, oily, forestry. That's where the upper quadrant. So this is also having a low volume too. Please make a note of it. But however, the two design environments both have low volumes. They have vastly different design vehicle weights. That's what they have to understand here. So the low volume roads, such as a farm to market road in a developing country, might have a bicycle as the typical vehicle, whereas a mining road might be designed to support a 500 or a 600 or a 700 tons of ton dump trucks. So what I wanted to say is that it is clearly that the payment design aspects of the two design environments are vastly different. That's why I always say that one size shirt cannot fit for everyone. We have to stitch the studs as per my requirement. So I cannot follow the principle, I cannot follow the design guidelines what adapted for the high volume roads. I cannot construct a 1 meter or 1.5 meter crust thickness. So from this picture, it is evidences that we have to design our shed, we have to design our payment as per the requirement without any compromise on the quality and performance of the roads. So that's what the background, that's what the definition of the low volume road is concerns. So how low is low in terms of the traffic volume and weights? That's what the concern of the points. So then coming to the next part is, sir, talking about the specifications. So before the 2000 year, there were very little sound knowledge was available on the planning, design, construction, maintenance of the low volume roads. But after that, once the rural road PMJS scheme was started, then the first ever kind of the manual, the SP20 in 2002. So the rural road manual IRCSP 20 was published by the Indian Road Congress as the first technical document, and subsequently the National Rural Road Development Agency constituted the purpose of the providing a technical and management support to the Ministry of Rural Developments. Then subsequent, we have gotten a very good number of code books followed by the design of cement, design of design and construction of the cement concrete pavement for the rural roads. That is IRCSP 62 2004, and as well as the flexible pavement IRCSP 72 2007. So, and followed by now we are using in a IRCSP 72 2015 is the latest code. So all these code books to provide in technical and management support to the MoRD. And later on, as you are all aware, in this process, they also developed a standard bidding document for the quality assurance handbook volume 1 and volume 2. Again, on the request, it has gone to the different revisions. First revision has been taken place. So the MoRD specification, which are developed in 2004. So on the request of the NRIDA, the IRC has brought out in a MoRD specification 2004. So 2004 to 2014, they have made a revision. So 2004 to 2014, there is almost 1 decade. 1 decade was there. So during this 1 decade, there is a lot of development in the country, lot of experience by the engineers like you, lot of the international exposures. They gained all those things. Then that has necessitated and also incorporation of the locally available materials, incorporation of the marginal materials, and also the different road safety aspects into it in the codal specifications, that has necessitated to revise and make the first revision mode in 2014, and also we are using an IRCSP 72 2015 as of now. So this is what the code of practices. This is the first 2007 the quality control, quality assurance handbooks. Now in 2016 there is a revision on this. There is available on the website, and this is the earlier version of the 2004 version of our MoRD specifications, and the latest word is this 2014, which talks about the innovative materials, which talks about the technology development, and which talks about incorporation about the new policies and regulation that has been introduced in the code of practices for all the engineers. So this is what the need, and this is what the little background of the MoRD specification, why they need a change and all those things. Now, before I move actually into the specification part, let me give you some idea. What are the quality works means? What are the role of the specifications? Sir, everybody feels that the civil engineering. What is the civil engineering? Anybody can do it. Moreover, that comes to our point of the road infrastructure. Road. What is road? Just excavate 1 feet or 2 feet, bring some material, dump into it, compact it, and leave it. Everybody can construct it. But you know that what makes the specification important, what makes a construction specification, all those things. So such kind of one instance what I experience or what we experience the transportation division. So this is the one of the road in Telangana. which is it is not a rural road. This is in a coal mining area road in a Singareni Collieries in Telangana. So this road has been constructed and this has been awarded for a third-party quality control test in contest to NIT Warangal. So NIT Warangal, the transportation division does a lot of consultancy on the third-party quality and all those for the different agencies. So these people, they requested us to do a third-party quality. So we have inspected this road and the road was found to be very good, excellent, there's no doubt about it. But what happened at some point of some chainage, while we are traveling on this or while we are walking on this, we have noticed that there is a small crack that has been initiated. There is a small crack that has been initiated on the top of the surface. Then we were asking the engineers, what could be, because the entire road is a excellent riding quality. We have not found anywhere any small crack and things, but this is the crack that has been given as a point of concern. Then I asked the engineers, sir, can we investigate this and see what is the problem? So we asked the engineers, what is your opinion? Then people are saying, sir, that it may be not properly compacted, and this area is mostly blessed with a block cotton cell area. So the compaction made the problem in the subgrade base layers. So we'll correct this. All those things will be given by the engineers. Now, in your opinion, what could be the reason for this, sir? With your experience in the field, is there any clue? Any? Pardon, sir? Can anybody give a clue? What could be the reason for this, or what is your idea? What is your thought process? Why this crack has been initiated? Any responses, sir? Okay. So very simple, sir. There is nothing that is miracle or nothing else. The simple reason, simple issue. It is because of this. Somehow, I'll show you in the next slide. Because of the presence of the wooden log, this has resulted, this has initiated, this made as initiated for the small crack initiated somewhere here. You can see this is initiated and now it is going slowly like this. So you know that during the traffic further move, it get widens, and it leads to some kind of distresses, and ultimately roads get the fail. This is what the reason. So what I'll tell you in the next 1 or 2 slides, what are the things in it. So we must be very careful while executing the work. See that there should not be any foreign material that has been presented in the mixes. Okay, maybe silly reason, but now this has initiated. This has caused to be cracking. That's what I wanted to convey to you. And there is a second experience for us. What we have done is, you see, everybody feels that road is a structure. We need to bury some materials into this, compact it, and forget about it. It's a buried structure. Who is going to worry? You and me, we are going to worry. You and me are going to think about this. So this is another kind of work that we have carried out in Warangal on the consultancy basis. So this is the road having 2 layers of grading 2 and grading 1, layer 1 and layer 2 of 100 millimeter thickness and 150 millimeter thickness, and supposed to be together it is a 250 millimeter. Look at the specifications. Nowhere it is a 250, either it is a more than 250 or it is a less than 250. Except this one case is a 255. And look at this picture highlighted. At this juncture, the contractors even forgot to lay one layer. This was a different story. he said that you are not performed the test in our presence. No, nothing happened like this. It was a discussion, but this is the reality. So specifications or material makes a lot of importance, lot of concern for us, all of us. Okay. So this is what the picture. So I have excavated the first layer. In the second layer, I myself took a crowbar and tried to hit into the layer where it was in. Simply it is going penetrating into it, but I could not feel of any aggregate that's present in it. So this is the zero. So with this background, sir, let us, you and me, we all of us know that. So these are these typical rural roads, which these photographs are. Yes, we are the photograph during our RRPPS studies. RRPPS, the study initiated by the NRIDA in 2007 to 2012. So these are the roads, and this is the most of engineers we have associated with the PMJSF from the day one, from the inception. They are very much familiar with this kind of payment cross sections. So we used to have a standard cross section like in a subgrade, embankment, and subgrade followed by a base or subbase as a WBM grade 3, WBM grade 2, as well as a granular subbase course. Okay, and the 3.75 75 meter is the carriageway width on this. This is the typical cross section. So now the latest code of practices, there are a lot of things, there are a lot of developments and changes has come into the different layers. So use of the marginal materials, locally available materials, and use of the cement treated bases. All these things have been incorporated, and we are witnessing today. So entire our life will be revolving around these layers. What should be the material, best material, what should be the properties, how they have been withstanding to the different traffic, environmental conditions. Our life is going to revolve around this pavement cross section, and see that end of the day, the road serves the purpose for which it was designed, intended, and constructed. So this is what the typical cross section of the low volume roads. And you know all of you that this is what the design templates. Design templates were given for the payment design for the gravel and granular based courses, and this is also a payment design template for the treated bases and subbases over to the original transaction of the payment for the low volume roads. Now let me give you a brief idea. Let me go further now. What are these supplements? New supplements that has been from the 2004 MoRD specification to the 2014 MoRD specifications. What are the general changes in the MoRD specifications? So these are the sections. Section 400 and 402, they supplemented within a gravel and soil aggregate subbases. Section 408, 410 as local and industrial material, which were not there earlier. So this has been incorporated. And also the semi-dense bituminous concrete and waste plastic has been in place now. And also followed with the steel, the structural steel, vented causeways, bridges, long span bridges, their bearing aspects, and also CC road maintenance, traffic signs, and most importantly added is the material, environmental, and social safeguard, which is a magic term that we are calling all using a road safety. So make a rural roads safer and safety, the magic term road safety. So in terms of that, how to safeguard the environment and the social safeguard, few aspects has been incorporated into this. So in addition to this also, there's a lot of quality control tests, quality control equipment has been added to the latest code of practices. So I will be highlighting these changes wherever they are done it, and remaining whatever not is highlighted, whatever not is listed, that is as usually maintained and continued from the earlier code practice to the current code of practice. And this code of practice also found a two bituminous constructions as was out. One is the built up spray grout as well as the modified penetration macadam. So you know that the built up spray grout has been recommended as a base course, and it is I think it is a 2-layer of composite construction and single size aggregate, and which is compacted on them. So both these are found something like susceptible to the penetration, open kind of a mixes, and the water is entrapped in this. So this has been found to be, this has not found any place in the latest revision of the IRC MoRD specifications of the 2014. And this is also has been given. I was telling you what are the materials, embankment, subgrade, unsuitable, and the requirements. Sir, I was showing the case study, unsuitable are the how to be careful. So if you present any kind of a foreign material, any kind of such kind of a things, that was the results. So they say that the material from the marshy areas were not recommended. They should be free from the peat or perishable and other organic materials. And also the material should not be spontaneously composite to combustible. And also they said that the liquid limit less than 75% and plastic limit less than 45. If you took at the MoRD specification higher order road, they said that liquid limit, the Utterberg limits less than 50 and plastic limit should be less than 45. And also the soils having any salts which is in a sodic soils we can call, which is having a pH value greater than 0.5, they are not at all suitable, they are not at all recommended for the any the subgrade or embankment constructions. And also FSI, free swell index. A soil which is having free swell index more than 50% should not be used as any filler materials. In case if you feel that there is no alternative for you, you have to use it. In that case, the code has given one concern that subgrade on top of 500 mm portion of embankment and below the subgrade, you have to ensure that it should be non-expansive in nature. That's what they have mentioned. In case there is no avoidance of the a free soil index, predominantly for the problematic soils such as the BC soils or expansive soils or OH soil something. And also, as coming to the material size, they are recommended that the embankment fill, the maximum size of the clod should be a clod less than 75 mm, and the subgrade maximum size of the clod less than 50 millimeters. Similarly, the maximum particle size, they said that 2/3 of the compacted layer thickness. Please remember to the 2/3 of the compacted layer thickness. So in the embankment, in the subgrade, the common material used is soil, boron, gravel, fly ash, slag, or any other, or the mixture of this material or combination of these materials can be used in a construction purposes. So when you are using the density, the compaction of the embankment and the subgrade is the density requirements. The density requirements, they says that embankment not subjected to any flooding, and embankment subjected to the flooding which is a greater than 3 meters height, and also the subgrade, earth and shoulder and backfill. You can see here 14.4 kilonewton per meter cube. This is the maximum laboratory die unit weight when tested as per our IS Proctor test. So they said that 14.4, 15.2, 16.5 kilonewton per meter cube respectively should be maintained and should be obtained. So when it comes to compaction requirements, so subgrade and earth and shoulder, should not be less than 100%, not less than 100%. When it comes to the embankment, not less than 98%. But whereas this case, this is in the earlier code in 2004, they said is a 97%, but based upon the experience or based upon the performance of the things, they said that it must be 98%. Similarly, we are all facing we know that the expansive soils are predominantly the BC soils. They behave very erratically in summer, they behave erratically in winter, different seasons. So for them also, they say that earlier it was mentioned, if I'm not mistaken, only the 90%. But in the latest code of revisions, they said the range has been given 90 to 95% on the expansive clays. So we know that a compaction is a key compacted parameter, and subgrade to be compacted in 2 layers, erosion also need to be taken care. Sir, let me make one point very clearly here. Subgrade. What is the function? What is the role of the subgrade? How the human being has been protected his body from the environment. How our skin is protecting us, your body. The same function does by your subgrade. If you are not properly constructing, properly maintaining the specifications, properly handling the subgrade, keep on building in a layers and layers and layers. It is a wastage of the money, wastage of the resources, wastage of the efforts. Your subgrade must be treated properly. You know that how painful we feel, all of us, when some injury, some wound happens on our skin. Similarly, a one hairline crack or a good crack that has been, as I showed, initiate on the top of the surface bituminous courses, and it slowly infiltrate into the lower levels and reach to subgrade. The damage may not be immediately, but over a period of time it shows. Must be so. We must be see that we must be constructed properly the subgrade. Otherwise, we are going to pay a heavy penalty later on these things. So that's what the subgrade embankment requirement as the code as practice has been given. Now, when it comes to from the top, the embankment and subgrade, the next layer is our the GSB layers. So as I told you, our entire life as an engineer, we will be revolving around this and using this kind of a traffic. So we know that the subgrade, subbase, base course, followed by a bituminous course. Whereas in a rural roads, now the people are using a SDBC or a BCU in some areas. But earlier, predominantly we used as a open graded premix carpet of a 20 millimeter, which is not treated as a structural layer. It is just as a dust palliative layer, and there is no mixed design procedure. It is simply a recipe of mix. You can say recipe of mix by adding some 3 to 3.55% bitumen on those things. Okay, so we will cover this part little later in the third day. Now let us consider this. So what are the functions of the role of the granular subbase layers? So you are aware the main functions is they should provide a drainage stability. Sir, if you recall our undergraduate level course on the transport engineering or payment engineering or highway engineering, all of you, we go from the bottom to the top. We use a low quality material to the superior quality materials. Predominantly in the subbase layer, we use a little inferior quality of the material, whereas in the top surface and in the base course, we use a very superior quality of material as they are taking the load directly from the traffic immediately of the things. So their role is they should distribute the traffic loads coming on the different layers safely on the subgrade without any excessive deformation or rutting or damage of the payments. So, and also the subbase is predominantly provided as a drainage layer, and we also need to be taken care about the capillary effect, that is the saturation of subgrade due to the groundwater table, and other layers also they should protect the subgrade and reduce the stresses that is coming over it, and it has to improve the load bearing capacity. And also one more important point is the initial stages. There are some sites, there are some areas which the even not capable of supporting any initial construction traffic. So they should provide a support of the construction equipments and construction loads during these things. So to have such kind of to have this roles layers, to have such to fulfill these objectives, we use a different kind of the materials. So what are those materials? So we use these are the materials, you're all aware of this. So natural sand, crushed gravel, crushed stone, crushed slag. Okay, so natural sand is a rock mineral by size of finer than the gravel. Crushed gravel, this is also a crushed slag. There's a crushed stones. This is the crushed slag, which is obtained from the steel industries and those things. Okay, and also we say that the CBR and the wet aggregate impact value. Wet aggregate value should be greater than 50. and minimum CBR is 20%, and which is relaxed to the 50%. What does it mean? That we said that the CBR value of the sub-basis should be 50%, 20%. So in some areas, it may not be possible to get a good quality of the materials. Okay, in those cases, the code has given a relaxation that a reliable of it can be up to the 15%. Now, in areas where there is a very soft aggregates are available, soft kind of local materials available, which can be used for the construction purpose. In those cases, code recommend that perform the wet aggregate impact value for the 72 hours soaking conditions. So after taking out the 72-hour soaking conditions, if their wet aggregate impact should be greater than 50, then that material also can be used in the construction in the construction process. So, sir, you have to remember all these things here. As Professor Prasad sir was mentioning in the morning, there was a lot of development in the construction of the rural roads today, in the technologies today. We are all facing in a crunch of the natural scarcity of the payment materials. I'm sure if you move another 30, 40, 50 years, definitely no, we will be having a very scarcity of the payment materials. That we are now itself we are witnessing that one, because you're all aware, those who are involved in the PMJSS scheme from the phase 1 on the inception of the scheme to the till today. If I am not mistaken, I remember that the average cost of the kilometer in the 2000 year, it was around started from the minimum 15 lakhs to the higher lakh to the about some 25 to 30 lakhs for the average cost of the kilometer. But today we are scrutinizing the DPRs. NIT Warangal is in a PTA and STA for the state of Telangana, Andhra Pradesh, both combined state, and not less than, sometimes I could see 100 lakhs, 1 crore, and average is not less than anywhere between 80 to 90 lakhs. When we ask the engineers, sir, what is this? Engineer says that mostly the scarcity of the materials. So one side is, this is the issue. Another side is, country is abundantly blessed, compared to the country, abundantly the alternative local materials available. But fortunately, unfortunately, as I said always, that God has not created all of us same height and weight and color and those things. So whatever the material that is available cannot be straight away used for the construction purpose, provided if we can make a little effort in treating these materials, at least 50-50 replacement or 60-40 replacement, something, definitely we can save the nature, we can save the cost, and we can also save the future younger generations, and they can be, otherwise they should not say my father and mother ate everything on this planet, they did not left for us anything, this kind of an issue. So that's what the requirement of the natural sand, crushed gravel, crushed stone, and those things are. So, and move to the further, the latest code of practices, they have introduced this new 2 gradations, granular subbase gradation and the gravel subbase. This is which is the natural gravel. Okay, so this is the grade 1, grade 2, and grade 3, and this is also for the subbase layer. The grade 1 and grade 2, there's the natural gravel within a subbase. This is a new incorporation in the subbase. This is a new incorporation in the granular subbase layer, and you can see the corresponding sieve sizes and the gradation size. And they also said that 75 in case of a clay subgrades. In case of a clay subgrades, this part, the material passing 75 micron sieve should not exceed the 15%. Okay, and also they given the rainfalls, some kind of earlier this table was not there. For this gradation, they are given 3 rainfall areas. If the area is something low, medium, and all, or normally we classified low, medium, high rainfall. So greater than 1000 millimeter, less than 1000 millimeter, irrespective of the areas, your Atterberg limits are this, and your plasticity index are this, and there is some kind of note that has been given. If for this, you can up to design traffic 1 million standard axles and up to design traffic up to greater than 1 million standard axles. Sir, as I told in my opening remarks, in India, low volume road means a road which is carrying a 2 million standard axle. That is as per the IRC SP 72 2015 latest. As IRC SP 72 2007, it was 1 MSA. If you recall your IRCSP 20, we have A, B, C, D, E up to a 450 vehicles per day. This is the year of 2000. Now we are also calling minimum a road which carries a 2 million standard axle. Earlier code, if they were greater than 2 million, if any road exceeds the 1 million standard axle, we used to recommend either you design it for a 1 million standard axle considering the same code of practice, or go for an IRC 37 2012 or 2018 for the design of a flexible payment, which is not my cup of coffee for the rural road is concerned. So now also a road which exceeds greater than 2 million standard axle, I don't see, except in a rare cases where there is an industrial area or there is an something sand quarries or iron quarries, something else. Otherwise, no question of rural roads are exceeding a 2 million standard if you are perfectly establishing the a traffic volumes and doing the systematic and scientific analysis. But this is the guidelines that has been given to us. PI for the granular subbase and granular subbase layer, which has been incorporated new with the CODA practices. Here also, minimum CBR 20%, and if the granular subbase not meeting the economic needs, so they said that 50% relaxation has been given for the engineers to take care of those things. And another new incorporation in this, they are given a modified definition for the gravel. So the new modified definition is saying that natural gravel. So natural gravel, if you try to have, it will be not less than anywhere minimum 30% CBR to the 80% CBR kind of materials are available. Okay. So natural gravel are a mix of crushed stone, crushed gravel, crushed slag, morum, sand, fine-sized particles, or any combination of this. This is the definition that has been given in the new definitions. And as I told you, we have a classical cross-section of the flexible pavement. In the subbase layer, which is supposed to be in a drainage layer, they are divided into two things, saying that lower subbase and upper subbase. Lower subbase will act as a drainage layer, upper subbase will act as a separation layer, with a minimum of lower subbase should have a 50% CBR and upper subbase should have an 80% CBR. And here also the wet aggregate impact value shall not exceed 40 and 50, 40 and 30 respectively. Flakiness index 25 and 20% for base and surfacing courses. And in this, by any chance, if the required material, gravel, soil aggregate mixes as a subbase material, base course and surface material, if they fail to meet your requirement, they say that go for a gradation by blending. That blending by crushing, screening, and mixing should be mechanically by in-place mix method that has been recommended in the MoRD specifications. And this is what this was the gradation soil aggregate, which is again a new, which was not there in the earlier CODA practices, and which has been. Hello.
Excuse me, sir.
Yes, please.
Sir, actually, we say that the CBR of subbase must be at least 20%. Now you are saying that upper subbase must have 80% and lower subbase must have 50% of CBR.
Yes.
But sir, that actually means we are using it as a base. We usually recommend that base should have CBR of approximately 80 to 100%.
Yes, sir. I'll address your issue once at the last of the presentation, sir. I understand. I address this once I finish this. Thank you. Thank you for your query. I'll address this. Okay, sir. Is it okay?
Sir, actually, if you will explain at this time, maybe at that time I may not be available, sir.
Right. Okay. Now, here earlier said I said that the sub-base course minimum so-called CBR value 20%. For the GSB, if the GSB is not meeting the economical need, they are relaxed to the 15%. Now, in this code, what is the gravel or soil aggregate? Gravel or soil aggregate sub-base, base and the surface course also. In this case, the sub-base is included in new revision. This sub-base includes a new revision has gotten a two things, lower sub-base and upper sub-base. So the lower sub-base and upper sub-base function is lower sub-base will act as a drainage, upper sub-base will act as a separation purpose. In this case, this is the 50, this material should have a 50%, this material should have an 80% in case of the gravel soil aggregate mixtures. That's what the only the inclusions are. But your natural
we are using very much. That means we are using superior material in sub base.
Yeah, sub base we are using a superior material also.
Sir, actually we must use a bit inferior, which must have CBR at least up to 20%.
Yes. But
if we are using material of CBR up to 80, then it means that we are not economizing the things.
Yes, that's what the code has recommended right now. This is things. So let's move further. So this is the aggregate gradation that I was speaking, sub-base and base, sub-base course and base course. This is a new inclusion that has been given in the early compared to the 2004 and 2014 this. And there is also a soil aggregate mixture for the surface courses. So this is the gradation, and this is what with a nominal size of 10 millimeter, and they are given for the high rainfall area, medium rainfall area, low rainfall area. It has to meet your liquid attribute limits and the Placid index requirements. So this is what about the changes that has been incorporated in the code of practice of the MoRD specifications. Now comes to the lime treated and soil improved subgrade. So as rightly said, wherever the material scarcity is there, when you are using a locally material which is not meeting the required specifications, the code has recommended to go for a treatment of the subgrade, subbase, and the base courses. So in this requirement, what they are given is physical requirements for the soil, sand, gravel, brick bats, crushed rock, slags, and the fly ash. So earlier it was mentioned that cement treated subbase and a base course. But now in the new revision, simply there is a change. They said cement stabilized subbase and cement stabilized base course. And they also given, if you are using going for a cement stabilized bases and sub-base courses, for a sandy soil, solid gravel, the range of the soil cement should be 3 to 5%. Silty soil with a plasticity index greater than 30 is 4 to 8%. Clay and BC soils 8 to 15%. And BC soils which are having a PI greater than 30, it must be addressed in a two-stage stabilization, that is a lime stabilization as well as the cement stabilization. Soil which are not responding, soil which are not getting improvement with the lime, the things, you can go for the second treatment with the cement stabilization, adopting this tentative. This is the range of the values that has been given for the cement content. And also in this case, the mixed design, you know that lime, the treated material, the mixed design must be confident in terms of your UCS value. So mixed design 7 days UCS is turned 2.76 MPa for a base, 3 MPa, and for 1.7 MPa for the sub-base courses. And also the soil, sand, gravel, conker, bats, and locally available material can be blunted, and then it will be compacted within the 2 hours. And the cement stabilization earlier code has given something. So in this code, they are mixed into the only one table with starting the 53, 37, 26.5 for the base and sub-base courses. The cement stabilization has been adapted. So here this is the one of the field study that we have inspected, sir. So this is the road in the Andhra Pradesh, in the state of Andhra Pradesh, in the Repalle, where there is the DE, and this is our Professor Ramanamurthy, and this is myself. About 2.5 kilometer of the road, purely block cotton soil. I think less than 1% CBR. They were trying to stabilize this material with the cement stabilization, and they are also going for an alternative, something like use of a geosynthetic, a geotextile material, etc. So somehow they have done a cement stabilization, and they are taken out the material for a strength purpose, and they are tested it, but they are not getting the required strength whatever I have quoted here. For the base course 3 MPa and the sub base course 7 MPa. So some of the engineers called us. We went there. We went and we have tested these roads, and we say that so nicely compacted road. Then we have just excavated it, and you can see in my hand the clod size in this hand and the clod size of this hand. This is the maximum. This is the maximum size that they could pulverize, and this is also another kind of a maximum minimum size they could be pulverized. And what we have done is we have taken a one lump and trying to see what could be the reason, what could be the fault. So this is what you can look at very carefully. Outer periphery is a cement coated, and inside there is no cement. You can see this. Now, whose fault is this? Is the fault of the engineer, or fault of the mixer design, or fault of the execution? Nothing. So what we feel is, in India, as even today, if at all we want to make a stabilization with a cement or a chemical or a bitumen stabilization, unless we have a state of the art of the machinery equipment which can use to pulverize this kind of a clots into the powder form and add to the cement, I think we will be getting this kind of results only. That's what my gut feeling. Unless we don't use in a state of the art of the machinery for the right now, what we are using, hardly we are using in a rotavators, or hardly we are using in a hard disk, or your tractor towed with a tractor towed cultivators. But these cultivators, this may not have a what do you call the required they have got their own limitations. They may not be pulverizing this material to the required powder form, these things. So this is also one of the reason, or main reason I can say, for the not successful of the cement stabilization or lime stabilization, when you talk especially about the problematic subject like in expansive soils or ABC soils or those things. Finally, we have recommended something to them. They have done it, and after that we also asked them to include the geotextile materials so that it'll get the extents, enhance the payment performance. Some solution has been given, but this is the reality and this is the fact. That is as the concern is concerns. And the granular courses has been concerned as a sub-base and base course. The traditional things, WM sub-base and base surfacing, no changes. WMM as a base course adopted. One of the new thing is, these are the two things which has been added. So we will discuss more about these two things in terms of the marginal materials or industrial materials, how to characterize, what are their properties, what are their quantifications. When we talk on the third day and the last lecture about the marginal materials, they're also given by me. So a lot of local materials have been suggested. Industrial material also been suggested. Something also good things, a plastic, use of waste plastic also has been given. Crushed and macadam, and also gradation aggregate should be met. And they also allowed that 5% deviation for the upper limit, upper to the lower limit of the gradation. And the screening material for the WM binder, a stone chips of size 13.2 mm and a stone dust of 11.2 mm all aggregates has been introduced in the as continuation to the traditional granular base courses and sub-base courses. Now, when coming to that, so we have discussed the embankment, subgrade, treated, granular layer, followed by the bituminous payments now, the prime coat and the granular surface. So you know that the bituminous course, whatever adapting now, on the rural roads is earlier was the OGPC, open graded premix carpet, but now some of the states are adopting even a BC. In Telangana, BC has been given. Some of the states adopting a semi-dense bituminous concrete, and some of the days we are adopting in some kind of a surface dressing or a mixed seal, something like that. So basically, it's a primer, slow setting emulsion, cationic emulsion is used. Code has recommended for the rate of applications in the court, and there are also a mix, cold mix technologies has been recommended. This also we talk much about the margin material day, which is no heating is required at the site. The tack coat of VG10 80 by 100 is used apart from the RS1 as quantity suggested in the code of practice. And we know that the bituminous macadam is an open gated mixture. And the new suggestion is that they are given that in a cooler regions, the bitumen content can be increased by 0.5%, and 50 to 75 layer using the paving grade bitumen, and VG10 to VG30. They said 3.3 to 3.5% for the crushed aggregate hot mix asphalt. The modified bitumen is not recommended, but the aggregate properties, grading, and bitumen quantity has been not changed, but it has been not recommended. So the properties of aggregate, grading, and bitumen quantities are same, more or less, they are continued. And the new inclusion is that inclusion in the mixing of the laying and rolling temperatures. So laying temperature, there was increased from 5 to 10 degrees centigrade over 10 degrees. Rolling temperature 10 to 20 degrees is increased. Sorry, as all of us aware, we know that we are following in a viscosity grade of bitumen, and we know that what is the bitumen temperature, aggregate temperature, material mix of the temperature, laying temperature, and rolling temperature. These are the things that we have received in the construction process. But at least my experience has said, if you say that a minimum is 100, it is around 80 in the site. It says that laying is 150. I have written something about it is about 100. This is because, see, sometimes what happened is our rural roads are interiors, and the mixed plant is somewhere located about 50 to 75 kilometers away from the road. By the time that fellow loads his truck and comes to the site, this temperature might have maintained at the bitumen temperature, aggregate temperature. But when it comes to the rolling and laying temperature, the exact temperatures are not maintained. This is also causing one of the main reason for the premature failure of the pavement. We can see in urban areas also, when they overlay it, very next day some of the mixers patch block the slide, or there is a lots of raveling, other things, because we are not maintained the temperature. That's why now that I read somewhere else they say that your mix plant should be located within the radius of 20, 25 kilometers, 30 kilometers, something. Some kind of class has been imposed so that this kind of a practical difficulties can be omitted. And surface dressing, I also not talk much about this. We have a separate lecture on the surface dressing. So here, modified bitumen is not recommended. It is deleted. Aggregate grading of nominal maximum grade side is 90 mm is added. Viscosity grading bitumen is recommended, and OGPC, open gate premix carpet with the VG bitumen is used, and this is the quantities. And new addition is now semi-dense bituminous concrete has been used as a surface course. Earlier it was a surface course in the MoRD. Now this has not found in the a place in the MoRD, but in the rural road. Now we are using an SDBC wearing course using a waste plastic are the new recommendations. So bituminous consumption, the finer cracks, the wider cracks. The finer cracks is SS1, slow setting emulsion is used. Wider cracks to be filled with a stone dust, which is finer than the 4.75. And code also given the semi-dense bituminous concrete mixed design requirements. So earlier, as I said, the OGPC doesn't have any kind of a mixed design, but semi-dense bituminous concrete has got a mixed design. So the requirements are this. So 75 blows on each side of the bitumen on the Marshall 4-inch diameter, and the minimum stability is 9 kilonewtons, and the Marshall flow. These are the parameters which is need to be ascertained in the laboratory, and see that if this parameter has to be and obtained by doing the semi-dense bituminous concrete mixtures and adapted for the rural roads. And when it comes to the other part, these are all the what do you call for granular layers, granular subbase layers, and all those things. There is a lot of changes also has been given in terms of the more bridges for the CD works and bridge works. So stone and concrete blocks, 200 mm concrete block of minimum strength 10.5 pi is added. Change in the cement content and the grade of the concrete also is added. So M15 to M45. It was in the old code, it was M10 to M30. Now it is a M15 to M45. And the minimum cement content is 343. The minimum cement content also will. Maximum is 450 kg per kilometer. Earlier it was 250 to 400. Okay. Now I think it is a. I think if I'm not mistaken, this is not the 450. I think this is also given a range. Please correct me. I think it is in the range of 340 to 380 kg per meter cube. Okay, and we are all witness to that on the rural roads now. The submersible bridges are deleted, and we have added a long span bridges, wells, and also piles foundation and other vented causeways as the low level causeway has been deleted, and submersible bridges has been deleted, and also recommended for a good well foundations, pile foundations, and all those things have been added. And minimum cement content, this is what I have given, 320 to 380 kg per meter cube, depending upon the type of the concrete and the severity of the weather. And removal of the formwork for the superstructure is 14 days after concreting the OPC. For vertical face columns like abutment, it is only a half day to the 2 days. Steels and also use of the new steel for a work. Don't use the re-rolled steel. No more is re-rolled steel. Use only the new steel. And for pipe culverts and vented causeway bedding pipes, there are two types given. Type A is fill more than 4 meter, less than 4 meters. Okay, and also NP3 or NP4 RCC pipe color 9 diamond inspection cases 600 mm to 750 mm dia. And if the cement concrete pavement is constructed over in a causeway of 200 mm thick, they said that M30 or more concrete, camber 2.5%, and joint spacing is a 4 to 6 meters. No submersible bridges if the velocity is greater than 6 meters per second. This is a very straight away. So NIT Warangal, I think we are cleared out around the some 600 to 700 long span bridges in the state of Telangana, Andhra Pradesh, also some of the other state nearby this. So we are cleared these things. I think all the rural roads now getting very good high level bridges. And also the velocity flow is less than, so also provided in stone pitching, a minimum of 25 kg and 40 kg for the apron as apron is concerned.
Excuse me, sir.
Yes.
Sir, how can we provide camber of 2.5% on causeway? Usually we have cross fall case of causeway.
Yeah.
We can't provide camber on causeway.
Why, sir? Why it's not? We have to ensure we should improve the cost slope only camber 2.5%. If you are using for the concrete pavement over in a causeway or 200 mm thick, I think we can provide the camber, sir. There could be any difficulty.
Yes, sir. Usually we have slope on only one side. That means cross fall. In case of causeways, in upstream we have edge on higher side, and on downstream we have edge a bit lower than the upstream.
Sir, your voice is breaking, sir. A little bit clear.
Sir, actually, I meant to say that usually on upstream side, the edge of the pavement is a bit higher. And on downstream side, pavement edge is a bit lower. We have cross slope only on one side. We have slope only on one side. We usually don't provide camber in causeways.
No, I'm not. See, if the cement concrete pavement, cement concrete pavement over a vented causeway, is there over vented causeway? I'm speaking, and it is a thickness is 200 millimeter, and if you're using a M30 or higher grade of concrete, the camber of 2.5% and joints of 4.6 meter apart is recommended in the code. So maybe practical difficulty may be there. I don't ignore that one. Maybe there, but this is what the recommendations. The new code of practice. And as the cement concrete pavement is concerned, so there are also a lot of changes in this. Cement concrete pavement is concerned earlier. OPC 33 was OPC we used earlier. Now OPC was removed. Ordinary Portland cement concrete 33 grade was removed, and the PPC slag cement grade of 43 or a grade of 53 has been recommended, and it is a mandatory. Now it is in a compulsory use of the fly ash with the 53 grade made an optional. 43 grade also fly ash uses optional. Fly ash is optional. Fly ash usage allowed. This is the one of the things as the fly ash is concerned. And this fly ash you are using it, they should conform to the what are the code specifications, IS specifications are there. When the cement content is concerned, cement content is 425 kg per meter cube and 350 kg per meter cube is the maximum minimum as recommended. The earlier code is 310 kg by the MoRD and 360 by the MoRD specifications. And there is also a lot of debate on this. What is the replacement? Cement replacement by fly ash. So this code MoRD said 30% is the maximum. But if you look at the international literature, if you look at the Indian literature also, there is nothing finally like a 30%. Somebody says 50-50, somebody says 60-40, somebody says 20-80, something. But the code in the MoRD specifications mentioned that 80% is the 30% is the maximum, and the maximum was not given earlier in the MoRD. It says 20%. So after fly ash additions, so this is the changes. And aggregate property, there is no change. As we see that Loss-Range aggregate value maximum 35, wet aggregate impact 30, flakiness index, water absorption. Water absorption is also a 5% maximum. No change in the water absorption also. And as the plain cement concrete is concerned, the maximum size of the aggregates, which is increased from the 31.5 mm to the 26.5 mm, M30 grade, and with this 28 days curing or 3.8 impart water cement ratio, then the slump is 30 plus or minus 10. And another important thing that has been given is the treated marginal materials. This is the one thing which has incorporated in the code. The marginal materials, what are the treatment, what are the options of those things. So this part we'll discuss a bit later. And also they introduced a roller compacted concrete. You know that roller compacted concrete is slump zero concrete. So they given cement content is 425 kg per meter cube, 350, earlier it was 310, and also the transfer contraction joints at the 4 meter spacing. Earlier it was PQC, saying that 2.5 to 3.75 meters. And this is what the gradation that has been given for the PQC, and this is the gradation that has been adopted for the your roller compacted concrete. And you can see previously it was 0.028, it is 0.5. And also there is a lot of impetus, a lot of emphasis on the rectangular concrete block pavement or interlocking concrete block pavement on the rural roads also. So these are the different changes, new supplements that has been incorporated in the latest revision of the MoRD specifications. So with this thing, sir, let me conclude. This is one slide, given a idea. As we know that we must be very proud. We are constructed in about 7 lakhs of the kilometers of the rural roads as in today in the country, and we must be very proud. So what are the real rural road indicator success, real indicator of success? So I feel that wherever when I present the topic on the rural roads, I used to show this topic, I used to do this slide. So I assume that we're all constructing a 1 kilometer of the road. Okay. So I'm giving an input as in 1 kilometer of the road. So in addition to the 1 kilometer of the road, I'm also giving an other factors, other socio-economic or environmental, weather or cost of the point of things. So this is what my grinding mixture. So it is grinding now. Okay. So the idea is, if you try to provide any connectivity or accessibility to the habitations which are not connected earlier. So what is the real indicator of the success rural roads is in the terms. So this is what my success path now. This is what my success path. My success path will give me. This is the output. That is time, education, cost, environment, health, trade, jobs and profits. So this is the typical, that's why I said, in my opinion, it is very easy to design, construct in a high volume road rather than the low volume road, where we are continuously striving for a cost effective methodology without compromise the quality and provide the daily needs of the rural India or rural communities. So these are all the time, education, trade, cost, environment, health and jobs. These are all at an individual level. Okay, these are all at individual level. Each one of us get a benefit. But we are celebrating the 75th independence. Azadi Ka Amrut Mahotsav of 25 years. We are all striving, we are all trying, all governments are trying for a one common single cause, which is nothing but a poverty reduction. So reduction of this, our rural roads, my rural roads will play a very critical and major roles in terms of this real indicators of the success. So with these things, I thank you very much for your kind attention and kind attention on these lectures. So I am very happy to